In the previous video, we took a look at a number of examples where we go through and be able to do some algebraic operations using MATLAB. What if we want to start doing some calculus operations? And the calculus operations I'm going to focus on is just basic derivatives and basic antiderivatives or integration. We have a I wouldn't say a difficult derivative, but it can get messy, all right, pretty quickly. So we might want to try to avoid utilizing the quotient rule as well as the product rule in the denominator for this. And we can use MATLAB to be able to evaluate this fairly simplistically. All right, so let me illustrate how we can use MATLAB to be able to find these sorts of derivatives. So first of all, I'm going to define a symbolic variable x. And let's define our, I'm just going to say our expression f to be, now if you look at what we had before, we had our 3x squared plus e to the x in the numerator. So we're going to have 3 times x squared plus exp of x. And then we're going to divide that by x times the arc sine of x plus 4. So we're going to say a sine of x plus 4. All right. So that's our function. I'm just going to call it f. And I'm just going to define f to be a symbolic variable as well. It doesn't have to, I think, in this instance, but it never hurts. And then I'm going to use the function diff. So I'm going to differentiate f with respect to x, right? And I'm just going to go ahead and run this. And it gives us our derivative, all right? Now, it's not necessarily the most simplified derivative, but it certainly is a derivative for us. If you wanted to take the second derivative, okay, which in this case will be pretty rigorous, all I have to do is just change this third parameter. And I just go ahead and enter a 2 there, all right? So if I did comma 1, it's going to give me the exact same thing. All right, but if I say comma 2, now check this out, then it gives me this really long second derivative. And of course, you can have some fun at the expense of MATLAB and get the fifth derivative. Not that you would ever need it, but you can go ahead and do it. And MATLAB, in a matter of seconds, will crunch out what the fifth derivative of that is. All right, so if you have nothing better to do, you can try to break MATLAB by saying, okay, what's the 10th derivative, etc. All right, so that's how you can do derivatives in MATLAB. Pretty cool, nice and easy. Now, let's say you want to go through and perform some integration in MATLAB. All right, so I have this integral, which is not an easy integral to evaluate. All right, you probably have to do some partial fraction decomposition. You can't use a u sub, unfortunately, it's really close. You could go through and use like some trickery, I guess, if you wanted to, by like adding and subtracting 1 and then factoring it and then doing a u sub, but it's a really ugly sort of integral to be able to evaluate by hand. All right. Now, let me show you that we can utilize MATLAB very easily to do this. So once again, what I'm going to do is I'm going to define the function f to be our 2x plus 1. And I'm going to divide that by our x squared plus 2x plus 1. All right, and I'm going to suppress that because I don't really want that. Now in MATLAB, I can use the function int. I'm going to integrate f with respect to x. All right, and I know that there are limits of integration on this. All right, clearly I can see that it goes from 0 to 3, but I just want to show you that you can do it without the limits of integration to get the general antiderivative. All right, and again, this would be a fairly rigorous sort of antiderivative to find. You'd either have to do some add, subtract magic or do some partial fractions. Now, if I want to get the limits of integration in there, I'm going to type x, I'll put f comma x comma 0 comma 3 in this case. All right, so 0 is the lower bound, 3 is the upper bound. And notice what it's going to do is it's just going to plug in 0 and 3 down here. So I should get like some 4s or something like that, right, somewhere in there because of the 3. And I get log base 16 minus 3/4, a pretty simplistic answer given the complexity of that integral. All right, so that's how you can use MATLAB to be able to evaluate the antiderivatives as well as the derivatives of functions. All right, so I'd suggest using MATLAB to maybe check some of your derivatives that are more rigorous or check your antiderivatives that are more rigorous. All right. So we're going to move on from here, and we're going to do a little bit more specific stuff with respect to your course in the next few videos pertaining to the first few sections of material cover.